Now, let us see what are the various Carnot principles. So you know that this is a heat engine which gives you the maximum efficiency. Efficiency of a heat engine depends upon the cycle which undergoes, and we will get the maximum efficiency for the Carnot cycle. So what is the Carnot principles? The efficiency of an irreversible heat engine is always less than the efficiency of a reversible one operating between the same two reservoirs. Okay, so this is the first Carnot principle. That means, simply means that a Carnot engine will be a Carnot engine is a cycle which a Carnot engine is a engine working on the Carnot cycle, and a Carnot engine will give you the maximum efficiency. Any heat engine between the same temperature reservoir will give you less efficiency than a Carnot engine. So, and the second Carnot principle is that the efficiencies of all reversible heat engines operating between the same two reservoirs are the same. That means if you consider same two reservoirs, almost all efficiencies of all the Carnot engines operating between these two engines will have the same efficiency. It will have the, so these are the two Carnot principles. We will try to prove these principles. Okay, let us try to prove the first principle, that is efficiency of an irreversible heat engine is always less than the efficiency of a reversible one operating between the same two reservoirs. Okay, so we will take a high temperature reservoir and a low temperature reservoir, and we will first consider an irreversible heat engine. It takes in heat QH and rejects QL, irreversible. So this is QL, irreversible. Then it produces an irreversible work, that is QH minus QL irreversible. And then you have an reversible heat pump. It takes in heat QL reversible and rejects QH. Okay, that is a reversible heat pump means this Carnot engine can be reversed to work as a refrigerator. So this is a reversible heat engine. That is what we mean by reversible engine. It can simply be reversed without any change in the surroundings. So this is a reversible heat pump. Um, so this works by taking in QL reversible and rejecting QH and taking in a work of QH minus QL reversible. So this is a how a reversible heat pump works. Okay, that means this is just a Carnot engine. There is a reversible engine. It works by taking heat and releases QL reversible. You can simply reverse it. That means you are taking in QL reversible and rejecting QH to the high temperature reservoir by taking in a net work that is equal to QH minus QL reversible. Okay, so we make an assumption that the work done in the efficiency of the irreversible engine is greater than this reversible pump. Okay, that's what we are making the efficiency. Efficiency of the irreversible heat engine is greater than efficiency of the reversible heat engine. See, this is not true. We will try to prove this is not. Try to prove this is not true. See, if efficiency is more, that means the reversible this work will be greater than this reversible work. Okay, so uh, so let us try to combine these two devices. There is an irreversible heat engine and reversible heat pump. So if you combine these two, that means make a single device. Make this into a single device. So the net heat exchange with the low temperature reservoir is QL reversible minus QL irreversible. This is shown here. So this is an irreversible heat engine. And you can remove this high temperature reservoir because this QH can be given to this irreversible heat engine. You don't need this high temperature reservoir. So this will become an irreversible heat. If you combine these two, this will become an irreversible heat engine which takes in heat QL reversible minus QL irreversible and produces a net work, because the work produced by this device is this much and work produced supplied to the reversible heat pump is W reversible is equal to QH minus QL reversible. Okay, so this W net actually will be equal to, if you use these values, it will be QL reversible minus QL irreversible. Okay, so that means this irreversible engine takes in heat, this much heat, and produces a net work of this much. So it produces an equivalent amount of work by exchanging heat with a single reservoir. Okay, exchanging heat with a single reservoir. So that means that violate Kelvin Planck statement. Okay, so this assumption is wrong. So reversible engines work cannot be greater than a irreversible engines efficiency cannot be greater than a efficiency of a reversible engine. So this is how you prove the first principle, that is efficiency of a reversible heat engine is always less than the efficiency of a reversible one operating between the same two reservoirs. Now let us look at the second principle, that is efficiency of all reversible heat engine operating between the same two reservoirs are the same. So that means we will take a high temperature reservoir, low temperature reservoir, a reversible heat engine which takes in heat QH and rejects heat QL1 and produces a work QH minus QL1. Okay, and we will take another reversible heat engine 2. Let us reverse this heat engine, that means it takes QL2 and rejects QH and takes in heat work QH minus QL2. So this is what happens. This is the so that means we are reversing the second heat engine, and we are assuming that the first efficiency of this heat engine is greater than efficiency of this heat engine. Okay, this is the assumption we are making. So if you are combining these two devices, see, if you are combining these two devices, you can remove this high temperature reservoir. That means you can just transfer this energy back to this reversible heat engine, and you can take the net heat exchange with this low temperature reservoir is QL2 minus QL1. Okay, so that means in a low temperature reservoir you can take QL2 minus QL1. So if let us just combine these two devices, so it will become an irreversible heat engine. It takes in heat QL2 minus QL1 and produces a work that is W1 minus W2. So W1 is this one and W2 is this one. And you don't need this reservoir, high temperature reservoir, because you're taking this heat and supplying it directly to reversible heat engine. Okay, so that means this violates Kelvin Planck statement because it exchanges heat with only a single reservoir and produces an equivalent amount of work. You take in QL2 minus QL1 and produce an equivalent amount of work. So this is also not true. So efficiency of all reversible engines operating between same reservoirs should be same. It cannot, so efficiency of one should not be greater than efficiency of two. This is simply not possible. So both the Carnot principle we can prove using the second law, how it violates the second law of thermodynamics.